OSPF network types. Earlier in our labs, we have seen OSPF supports broadcast, OSPF supports point-to-point. Whenever you are connecting two routers that runs OSPF using a serial link, we call it as point-to-point. You got two routers, R2, R1, and they run OSPF, and you are connecting via using a serial link. Whenever you use serial link, the encapsulation type is HDLC in Cisco. In non-Cisco, it is PPP, point-to-point protocol. Now, OSPF can see this encapsulation type. Even though OSPF is a layer 3 protocol, it can still see the layer 2 encapsulation. So when it finds the encapsulation as point-to-point or HDLC, it will say this is a point-to-point network type.
Jay?
Point-to-point network type. Yes, sorry.
Jay, sorry, could you brief a little about these encapsulations,
Okay.
point-to-point HDLs? How does the packet look like?
Okay. See, whenever we have Ethernet wire connected to the router and OSPF runs on that Ethernet wire, because you advertise the network which is configured on that Ethernet wire, OSPF will say it's a broadcast type because it is Ethernet encapsulation. The layer 2 protocol, Ethernet, and PPP and HTLC, they all don't do the encapsulation the same way. They do in a different fashion. They're basically layer 2 protocols. Ethernet is a protocol, PPP is another protocol, HTLC is another protocol. Only on the serial link HTLC and PPP is possible. That type of encapsulation is possible. So whenever PPP or HTLC is seen, OSPF understands that you don't have more than one neighbor. If it is PPP or HTLC, OSPF knows that you cannot have more than one neighbor because it's a serial wire. Only a serial wire can run PPP or HTLC. So as soon as it finds this encapsulation, it knows that there cannot be more than one neighbor. The OSPF network type becomes point-to-point. If it is point-to-point, there is no need for DR-BDR election. There is no need for DR-BDR election. Only during the adjacency state, you will see master and slave, after which they are all same. There is no master, there is no slave, there is no DR, there is no BDR. Whenever we have Ethernet as encapsulation, then the network type is going to be broadcast, not point-to-point. Broadcast, it will be broadcast. Network type will be broadcast. Why? Because with the Ethernet wire, you can connect to a switch and you can have more than one neighbor. In serial, you cannot have more than one neighbor because it's a serial wire. you don't have any switches like you have Ethernet switches. You don't have a switches. You don't have any switch for serial. Serial is always WAN interface, which means point to point. So whenever we have Ethernet as encapsulation type, even if you don't have more than one neighbor, still the network type is going to be considered as broadcast. In broadcast, there is going to be a DR BDR election. You see, same router 1, router 2. But this time I'm connecting through a Ethernet. Or it can be a fast Ethernet also, that doesn't matter. Whenever you have Ethernet or fast Ethernet or any Ethernet, gig Ethernet or any Ethernet, OSPF will make the network type as OSPF will consider as broadcast network type. Broadcast on either side. Why? When you have Ethernet, you can connect a switch and you can have more routers, more neighbors. So those routers that you may connect or you may not also. You may not also connect multiple routers. You may have only one router, but still, whenever you have Ethernet as an encapsulation type, OSPF assumes that you may have more than one router as a neighbor. So there should be a DR BDR election to avoid duplication of update, which will result in loop. So there will be a DR and there will be a BDR. The one with the big router ID becomes DR. The other one is BDR. These two we have already seen. Now what we are going to focus is NBMA, non-broadcast multi-access. What it is, you're going to have neighbor, one or two or three or four neighbors. In between, you got a non-broadcast environment. Non-broadcast environment.
Jay, is frame relay a non-broadcast
Yes,
access?
correct. So you got frame relay. I know we have seen these things. I'm just revising these things with presentation, so you
Any
can
other
recall.
examples?
Come again?
Any other example for non-broadcast multi-access?
There is no other well-known, but there was X.25 ATM, but nowadays no one uses that. Frame relay was the last NBMA environment we had in our industry. Before frame relay, we had ATM, and then X.25, but not many people know about it. Okay, so this is the only example right now. There's no other example you can give as non-broadcast. Your internet today supports broadcast, multicast, allcast. But early days, we had frame relay to connect remote sites, which was not supporting broadcast. Before that, frame relay, we have X.25 ATM. Anyway, we have this frame relay at least to explain you what was here earlier. You may ask like, why are you learning? Why are we learning when we don't have non-broadcast multi-access? I asked that same question some weeks before. in this class. I already answered the question also. Why we are learning this? Because in this NBMA, we got 5 modes. OSPF operates in 5 different ways in each mode. 5 modes. This is OSPF mode, which can be configured under the interface, so that when you have NBMA, OSPF will be operating on top of it as per your policy. So to see which mode suits our policy, we need to know all 5 modes. Each mode is different from other. That's why we have 5 modes. In this 5, one may be suitable for your requirement. So that's why we have this 5 mode. But again, we don't have NBMA. Then why do we need this 5 mode of NBMA? See whether you have NBMA or not. This 5 mode is OSPF. OSPF's 5 mode. It is not dependent on frame relay. So if you like this 5 mode, or if you like any one of this 5 mode, the way that the mode operates, you may go and configure that even in a broadcast environment. If you go and configure the mode that you want, it will behave like an NVMe mode. See, I repeat. In NVMe, there are 5 modes. Today, we don't have any frame relay. Few claims that they have it. Let's assume there is no frame relay. Now, why do we need to know this? This is to know the difference between these 5 modes so that you can use this even in an Ethernet environment. If you like behavior of one of this mode, OSPF behavior, when you put one among this 5 mode, you can still use it in an Ethernet environment. For example, you want the neighbor to be statically configured, manually configured. You don't want dynamic discovery of neighbor. You don't like OSPF to discover neighbor dynamically. If that is your requirement, you can go and enable the mode called non-broadcast. Mode called non-broadcast. Even though in an Ethernet environment it is broadcast, because you said OSPF mode as non-broadcast, it will assume as a non-broadcast environment, and it will behave as it behaves in a non-broadcast environment. That's why we are learning this. Now, I just finished talking about this page. Kindly go through this. Let's move on to the next page. Whenever you have point-to-point, this is not NBME mode, this is normal point-to-point, you have a serial wire. Whenever you've got point-to-point, the encapsulation type will be either PPP or HDLC. In NBMA also you have a point-to-point. There's 5 modes, no? One of the mode in NBMA is also called as point-to-point, where you will be having frame relay or ATM or whatever. We'll talk about that when we go there. Now, in point-to-point, whether it is NBMA point-to-point or simply point-to-point with a serial wire, there is no DR-BDR election. That's the important point. There is no DR-BDR election. In a point-to-point environment, there is no DR-BDR election.
Why not, Jay?
Because there is only two routers. See, when we have many routers, there is chance for loop because of duplication of LSAs. You see, you got 5 people in your team, and there is a task need to be done by the team. And you're saying to Ravi, hey Ravi, kindly do this task. But Ravi is sending this task to all others. Or let's say you say, hey, we have to do this task. That's all you are saying. You're not saying, Ravi, you do this task. You're telling, hey, we need to do this task. Ravi thinks that you are talking only to him, but actually you are talking to everyone. And everyone thinks that you're talking to them personally. So what they do is they spread this information to all others, but all others have already received it from you. But now they are receiving it from others as well. That becomes duplication of same update repeatedly. Whenever there is a duplication of update, there is going to be a loop. To avoid that, what we do is, in our team, we select one team leader. Whenever someone has got something to say, they won't talk among themselves, they will talk to team leader. And team leader will inform this to others. In that way, there is no duplication. That is what DR. Whenever you have many routers, whenever you have broadcast environment, you have many routers. Whenever you have many routers, there will be a DR collected to avoid the loop. In point-to-point, there is only 2 members in the team, just you and me. If you say something, it is going to come to me. If I say something, it is going to come to you. And how there is going to be a duplication? No duplication. There is no loop possible. So there is no DR-BDR needed. There is no DR-BDR required. Not necessary. So wherever there is serial interface or HTLC, OSPF can auto-detect the interface type as serial or sorry, point-to-point because it is serial link, and there won't be any DR-BDR election. If there is no DR-BDR election, there is no need for 224006. There is no need for 224006 because you just got 2 routers, you and me. There is only one address, more than enough, which is 224005. So OSPF point-to-point network will use only one multicast address, which is 224005, to send a hello package, sometime even to do some notification, some updates. It uses this multicast address. Sometimes it also will use unicast. It depends on the query. That's about point
So
to.
basically, yeah, basically in point-to-point, we don't, there's no, I mean, there is no use of 224006, right?
Because there
Only
is no
005.
correct. Because there is no DR-BDR.
DRPDR, correct.
Dot 6 is the address that we use to talk to DR. Dot 6 to 24006 is the address that we use to communicate something to this designated router. Because you don't have designated router in point-to-point, You don't have any designated router, so there won't be any use of 224.0.0.6. OSPF is not going to use it. Fine. In a multi-access broadcast network, meaning you have an Ethernet wire. See, this represents what? A switch, layer 2 broadcast domain. Whether you have switch or not, if you're having Ethernet wire, OSPF will assume that you have a switch. So OSPF will conduct the election, DR-BDR election, and there will be one DR and one BDR selected. So there is going to be a designated router and backup designated router. We have spoken about this based on the priority, highest priority, a DR is elected. The router with a high priority. You can go under the interface and say IP OSPF priority and a number. You can give a number. Smaller, less preferred. 255 is the biggest number. If you say IP OSPF priority 255, then this is the router elected as the designated because this has got the highest priority. By default, the priority is 1. Fine. So when there is a tie in priority, it is going to compare the router ID. The one with the bigger router ID becomes the designated router. And for a backup, there will be a backup designated router also elected. This is not a new story. We have already spoken about this earlier. Every router will form full adjacency with this DRs. When I say DRs, it includes both DR and PDR. What does that mean by full adjacency? You remember we learned 7 adjacency stages. Full adjacency is start, exchange, load, and full. That is full adjacency. Between other routers, they only go up to two-way adjacency, two-way stick. So any packet that need to be delivered to designated router, multicast address 224.0.0.6 will be used. And if the DR wants to inform some new updates to others, it will use 224.0.0.5. So here in broadcast environment, we see there are 2 multicast addresses used. 224.0.0.6 is to DR, 224.0.0.5 is from DR to others. This is what I just finished talking. The one with a high priority becomes the designated router. And we see here a router with priority 3 becomes the DR. The command to configure this is go under the interface and then say IP OSPF priority. IP OSPF priority. 255 is the biggest number, 0 is the lowest. If you put 0, like it is said in router C, if you put 0, that router will not participate in the election. Even if it has got the bigger router ID, no use, because it is not going to participate in the election. Any router with priority 0, they are not eligible to be the runner in the election. Fine. So priority 3, priority 2, priority 1, there's a election. And priority 3 router wins the DR, priority 2 router wins BDR, and the other routers A, B, they are DR others. So between A and B, there will be only two-way relationship. Between DR and all other routers, there will be full adjacency. Likewise, between BDR and all other routers, there will be full adjacency. If in case the priority is tie, then there will be a tiebreaker router ID. The biggest router ID wins. This last point is somewhat important. The DR election is a non-preemptive. What is non-preemptive? Once a router becomes DR, it will remain DR even if a superior hello packet comes. See, for example, you configured this router. First, you configure this router. When you are configuring OSPF on this router, there is no other router running OSPF. There is no other router running OSPF. Only this router is running OSPF. So after waiting like 30 seconds, 30 to 40 seconds maximum, this will promote itself as a designated router. Now if you bring this router with a high priority, it's of no use. No use. Why? It's non-preemptive. If one is elected as a DR, elected. Whoever comes, it won't give up the position. So sometime when you do the lab, you will see a router with a small router ID, small priority, becoming a designated router. It is because you configured that router first. And when the election was conducted, there was no competitor there is no competitor, or sometimes you have competitor, but you don't have that one with the high priority there in the field to compete. So what we see is, if you know next there is going to be a person elected as a CM or PM, put him in jail during the election days. Put him in jail for few months so that he will not compete. And this fellow culprit becomes a CM or PM. Now you release him from jail. Can he become a PM or CM? Not possible. Because CM PM election is non-preemptive. If he needs to become a CM or PM, this man should die. A re-election need to be conducted. Right. So you understood now what is non-preemptive. Once elected, if even a joker is elected as a PM, he will continue as a PM. Whoever comes, the wise man, even from heaven, if someone comes, the joker will be continuing as a CM or PM for another 5 years. That is what Constitution. That's what OSPF. It's non-preemptive. Even if a superior priority device comes online, this designated posting, which is already given to this guy, will not be given to the other person till re-election happens. I told you, this is the way that we can configure priority. Go under the interface and say IPOSPF priority and then a number. The higher is more preferred. Zero means they cannot compete. They cannot become a DR. One is the default priority. The router that is not a designated router nor a backup designated router will be called as designated router other. Now, what is NBMA topology? This is what NBMA topology is. We have single interface on each router. You got only single wire, single physical serial wire connecting to multiple sites. But to connect to the remote sites, we use a non-broadcast environment which is not capable of supporting broadcast. Example, you got X.25 frame relay, one of this. This is what you call it as non-broadcast multi-access because you got multiple sites. Each router has got 3 remote sites. So the designated router election in NBMA topology, if you have full mesh, then it is good. If not, it is useless. For example, let's say you don't have full mesh. You got connection like this. Is this full mesh? No. This is hub and these are spokes. Now, if this is a designated router and backup designated router, if designated router goes down now, this tunnel, all tunnel will break. There won't be any connection between the sites. Tell me, what is the use of this DR-BDR? There is no use. As soon as DR goes down, the tunnel will break. There is no connection between the sites. All fall down. Now what will happen? Because there is no one, this will say I am DR. This will also say I am DR. This will also say I am DR. What is the use? There is no use because there is no tunnel anymore. The hub goes down, all the tunnel went down. So there is no point of having DR-BDR election if you don't have full mesh. If you don't have full mesh, don't have DR-BDR. What is full mesh? This is full mesh. All connecting to all. Now if you have DR and BDR, others, DR others, if this DR goes down, yes, it's okay. Only these 3 will fall down, but the other connections are still there. Only these 3 will vanish. It is okay. Now this will say I am DR, and this will say, let's say, BDR. Good, no problem. Still the DR-BDR is valid. If it is full mesh, the DR-BDR is needed to have full mesh connectivity with all other routers. But NBMA networks are not always full mesh because it is costly. NBMA Means what? Frame relay. You have frame relay connection to this office, and this office. You already have communication between all your spokes, all your branch office. All these four companies or all these four sites are already communicating. So you will not spend more money now to have another tunnel between this and this, this and this, this and you won't spend that money because it's costly. That is why they are saying not always full mesh. NBMA networks are not always full mesh. So there is no need for DR-BDR election in that case if you don't have full mesh. And in non-broadcast environment, because it's a non-broadcast environment, there is no multicast support. How do you discover neighbor? By sending hello packets. What do the hello packet use? Multicast address. If multicast is not supported in this cloud, how you will send a hello packet? Not possible. So there is no neighbor dynamic discovery. OSPF neighbors are not automatically discovered by the router in an NBMA non-broadcast environment. Now, to overcome all this difficulty, to make OSPF to consider NBMA to be like a broadcast, you need to learn those modes. Before we get into the modes, let me first talk about this page. Different type of frame relay topologies that we used to have in those days, frame relay days. This is very costly, as I told you. Every site is connected to all other sites directly. This is the cheapest one, hub and spoke, and this is a little bit costly because you got some additional connections like partial mesh. So whenever you have full mesh, you can have a mode that will have DR-BDR election. Whenever you don't, then you should choose a mode which will not elect DR-BDR. We are going to learn 5 modes in which a mode will have DR-BDR, some will not have DR-BDR. That's why we are learning these 5 modes. Now, NBMA modes, 2 are RFC, 3 are Cisco. RFC 2328 talks about these two. So all vendors that has got OSPF support this 2 mode. Only Cisco has got additionally 3 modes: point to multi-point non-broadcast, broadcast, and point to point. See? So non-broadcast is the default mode. The other 4 you can change if you want. Whenever you have frame relay or extra 2.5 or ATM or PPP, sorry, not PPP. Whenever you have frame relay or extra 2.5 or ATM, PPP is not non-broadcast. PPP is point to point. Whenever you have frame relay X.25, see, we run frame relay on serial link. PPP also runs on serial link. If you change the encapsulation type from PPP or HTLC to frame relay, it becomes a non-broadcast. In non-broadcast, the neighbors are not dynamically discovered. This is the command to configure frame relay, and this is the command to change the mode, IP, OSPF, network type. If you don't like non-broadcast, which is default on frame relay interface, in frame relay interface, non-broadcast is the default. If you don't like, you want to switch to, you want to make the serial link to behave as if it behaves in a broadcast environment. Yeah. NBMA topology supports multiple routers but without broadcast. Yeah. Because it is not supporting broadcast, because it is without broadcast capability, the neighbors will not be dynamically discovered. But if you say, no, I want neighbor discovered dynamically, then you go and say, OSPF, consider this non-broadcast as broadcast. Just try to behave as if you behave in a broadcast environment. So it will start discovering neighbor dynamically. Let me repeat. Whenever you put encapsulation frame relay, the default network type will be non-broadcast. And if you don't like that way that non-broadcast behaves, you just want a broadcast approach. You don't like the non-broadcast approach. You want the broadcast approach. Then you can go and say, I want broadcast approach. Even though it's really a non-broadcast environment, it won't behave like a non-broadcast environment. OSPF will behave as if it behaves in a broadcast environment. Now, to understand this, you need to understand these modes so that you can go and choose one mode over the other. It's just an example to show how to switch to a broadcast mode from a default non-broadcast. This is the command. IPOSPF network point to point. You can say point to point, or you can say point to multi-point, or point to multi-point non-broadcast. You know? Now this is talking about the very first mode called non-broadcast. As I told earlier, this is the default mode. Non-broadcast mode. All serial ports are part of the same. Yes, here this is the important story. The neighbors need to be statically configured. And there will be DR-BDR election. This is not in detail, okay? I have given you these topics in whiteboard very clearly, those five modes. I want you to refer that. And I also remember we did this lab. Have we done this lab? 5 modes NBMA. Do you remember we have done the lab with frame relay? Rahman?
Yes, sir.
Rahman?
Yes.
5 modes. Okay.
Can you question please again?
Yeah, 5 modes we have already done.
Yep.
You know,
Yes, correct.
that is more clear than this presentation. I want you to go through that. I have given you points like what is non-broadcast. Neighbors are manually configured. There is no there is DRBDR election, and timers are 30 and what is the timer in
120.
120, and then recommended only if you have full mesh. Go through those things. So point to multi-point. In this, neighbors are dynamically discovered, but there is no DRBDR election. Timer is same 30 and 120. This is okay if you have full mesh or partial mesh or star topology because there is no DRBDR election. Next is point to multi-point non-broadcast. This is Cisco's, in which there is no DRBDR election. There is no DRBDR election. Neighbors need to be statically configured, and the timers are same 30 and 120. All should be in same subnet. This works on both physical and serial interface. Next is point to point, which works on sub interface, where the neighbors will not be in same subnet, they will be in different subnets, like this. You see, here 192.168.1, here it is two different subnet. So you got sub interface. This is point to point. The timer here is 10 and 40. 10 and 40. We have seen this. I'm just walking you through one more time. Non-broadcast is the default mode. Because there is a DRBDR recommended, I recommend full mesh. But not hub and spoke. Partial is also okay. Timer is 30 and 120. There is DRBDR election. This is RF. Next is point to multi-point. This is also RFC. This is okay for any topology. All should be in same subnet, 30 and 120. There is no DRBDR election. Here neighbors are manually configured, here dynamically discovered. Next is point to multi-point non-broadcast, which is combination of these two, where there is no DRBDR election, so any topology is okay, same subnet, 3120, neighbors are manually configured. This is Cisco's. Next is broadcast. You need to have full mesh because there is going to be DRBDR. Timer is only 10 seconds, all are in same subnet. This also Cisco. Even though it's a non-broadcast, it will behave as if it behaves in a broadcast. Point to point is needed only when we have different subnet for each spokes. So you will create sub interfaces and you will configure there won't be any DRBDR election because it is point to point. And this also Cisco's.
And point to multi-point, number 3. Point to multi-point, the adjacency is dynamic, automatically, because it's in the same subnet, right?
Yeah.
And no DRBDR,
Yes.
because there is no only the partial mesh.
Yeah.
Is the reason?
No, this mode is designed to support partial mesh, so there is no DRBDR.
Okay.
See, whenever the word point comes, there won't be DRBDR election. Whenever there is a word point comes, point to multi-point or point to point, wherever there is point, PYNT, there won't be DRBDR.
Okay, that's a good point to remember. And point to multi-point, it means on the same subnet and automatic automatic, the neighborship gonna start, yeah?
Yes,
Okay.
correct. Some of the verification commands, whenever you are struck somewhere, OSPF is not forming neighbor, then you can use this command debug IP OSPF adjacency. There is no adjacency word. You need to simply type ADJ. That's all. It means adjacency. It's going to show you the adjacency states. All right. There is also one more debug command, debug IP OSPF events, which will also show you the hello packets, how often they are sent, and from where to where it is going. So this chapter was about network types. Again, it's an important chapter. A very lengthy chapter it used to be because we used to do a big lab in BMA lab, but because we have done already, we are going to next chapter. Link state advertisements, LSC types.
Jay, I
Yes.
have to drop now. I hope this.
See, OSPF is a link state routing protocol. It uses link state advertisements to build the database. But the advertisement is of various types, various LSA types we have. We got different type of advertisements. Some advertisements are within areas. Some advertisements go across the areas boundaries. They cross the area borders. Some advertisements comes from other autonomous system inside OSPF. Some advertisements are IPv6 only advertisements. Some advertisements are only if you configure an area as a non-broadcast multi-access. Like this, advertisements are of various types. Like we have local advertisement, national advertisement, international advertisement. We have different type of advertisements. We have this type of advertisements because we have many areas. If you simply have one area for the entire autonomous system, entire office, then the routing table will be too big. And every now and then, when there is a change happening, the OSPF need to be keep on running. Number of advertisements that will be flooded will be too many. To avoid all this, we go with a hierarchy design with a backbone area connecting all other areas via backbone area. Backbone area connecting all other areas. Here, when we do this, we can reduce the flooding of advertisements throughout the autonomous system. If there is any change, that change can be localized within an area either by configuring summarization or stub. This reduces the routing updates. So hierarchical design is what recommended, and OSPF highly support recommends and supports. When you have multiple areas, there will be an ABR in between area 0 and the other area. Between area 0 and the other area, there is one common router which is connected to both area 1 as well as area 0. We call it as area backbone router, ABR. The other routers are internal. If it is in area 1, it is internal to area 1. If it is in area 0, it is internal to the backbone area. Area 0 is called as backbone area. Now this router where you see a cloud connected at the bottom, that router is the place where we redistribute from routes from external autonomous system into OSPF. That's the place where we take routes from EIGRP and give to this OSPF. This is the redistribution point. We call this router as ASBR, Autonomous System Border Router. These terminologies, these terms are necessary for us to understand the coming LEC types. ASBR, Autonomous System Border Router. This is the place where we do redistribution from external source into OSPF. Before we get into LSA types, it is also important to know about virtual link. Virtual link is a temporary connection that we establish between area which is scattered like this. You see area 0 is scattered here and there. But for an autonomous system, you cannot have two area 0. For an autonomous system, you cannot have two area 0. There cannot be two area 0 in an autonomous system. So how do you combine? We combine by connecting through a link, a virtual link, so that it becomes one big area 0. One big area 0.
In here, like I have a question. In OSPF, all area needs to be connected with area 0.
Yes.
Okay. Like for now, for like a scenario with area 0, we have one area 12, and with area 12 we have one more connection like area 13. But with area 13, there is no connection with area 0.
That is also a scenario.
In that case, okay.
That is also another scenario where we can use virtual link.
Okay.
See,
this is another scenario.
This scenario, which I am showing here, is what many people don't know. That's why I'm using this.
Okay. Yeah.
But what you are saying is what the common use case of virtual link.
Right. Okay. Thank you.
Welcome. So, what our Rahman says is all area must be connected to backbone area, but for some reason, one area is connecting to another non-backbone area. What might be the reason? Because there is no lengthy cable to connect to area 0, something like that. So, area which is non-backbone connecting to another non-backbone, how it will work. By default, every area should be connected to a backbone. So we connect this non-backbone, which is connecting to another non-backbone, via a virtual link. Yeah. So virtual link is a temporary link. It should not be for long. Like we use a physical link, it cannot be a permanent solution to connect a backbone area. For time being, you may use, because if you use a virtual link, then the bandwidth consumption over this path, the virtual link path, the area which is converted as a virtual link is going to be double. The bandwidth consumption is going to be double. Let us assume that this is area 0 and area 1 and area 10. Assume this is area 10. Area 10 should be connected to area 0 directly, but in this scenario, area 10 is connected to area 1. If it is connected to area 1, then the roots of area 10 will not be seen in any of the routers in area 1 nor in area 0. Routes of area 10 will not be given to area 1 or area 0 because without area 0, area 10 cannot distribute the route. Without area 0 in the middle, area 10 cannot distribute the route to area 1. Area 0 is mandatory between area 10 and area 1. So what we do is we convert this area 1 as a virtual link. Between these two routers, we are forming a virtual link, but what is used as a virtual link? The routers of area 1, the links of area 1. So what happens is, as I said earlier, area 10 cannot directly distribute the route to area 1. So it will go and distribute to area 0 and area 0 will distribute to area 1, which is double the amount of bandwidth. That's why it is a temporary solution, not recommended for a long time. So configuration command is like this. We'll do a lab. If we have not done earlier, we will do a lab. Have we done a virtual link lab before?
No, we haven't done
We
any
have not
virtual
done.
lab right
Okay,
before.
we'll do this lab.
No.
So we're going to see virtual link. You see the area 30, for some reason, it's not connected directly to area 0. So the routes that I'm going to advertise from router 8 will not reflect in router 3, router 2, router 1, 4, 6, but it will be there in router 5 because router 5 is also a member of area 30. Router 5 will see 88888, but it will not give to router 3. Why? Because 8888 is coming from area 30. Router 5 can give only if it has got a link to area 0. Because router 5 don't have link to area 0, it will not give to anyone. So what we have to do is we have to put a link between R6 and R5 so that R5 will also have a link to area 0.
And sorry, if there is a route in the middle, one more router in the middle, R3 and R5.
Okay, we'll do it.
Like
We'll do it. R3 and R5 and R8 is going to be the border.
Sorry,
No, that's a good
understanding.
idea. That's a good idea. That's good. So we're going to have 9 here, and then I connect a link. Okay. So you see, this is all right. So because we don't have connection between 8 and 3, 8 don't have connection to loop area 0. 8 has got no connection to area 0. So any route that is learned from non-backbone area will be only given to a backbone area. Area 30 is a backbone, non-backbone area. Area 30 is a non-backbone area. Yeah. Area 30 is a non-backbone area. This route 9.9.9.9 will be reflecting on router 8, but router 8 will not give to router 5 because router 5 is in area 20, not in area 0. So we need to somehow connect a wire between router 8 to area 0 so that whatever router 8 has learned from router 9, it will give to area 0. One way is having a physical connection, but assume that there is no possibility of having physical connection. Maybe the building in which R3 is too far from the building where R8 is. So immediately you cannot get approval for putting a wire between buildings inside the campus. So you need a temporary solution. So temporary solution is virtual link. You're going to put a link, right? So that is going to be a virtual link now. So before we go and do that, I have to do some basic configurations. R5 is not configured on this side, and R8 is totally not configured. R9 and R8 is 0 blank. Let me start from R9. R9 has got no configuration. I just added this show IP interface brief. Nothing. I'm going to use a notepad to finish it first. Enable config T interface F0/0 no shared IP address 10.58.0.9. Is it 58? So 58 I want to give in between these two. Let me give 89. 0.9.255. Then interface loopback 0 IP address 9999/32. Interface loopback 1 9999.1/32. Router OSPF 1 network 9 area 30 network 10.89 area 30. This goes on router 9. Done. Now for router 8 is also blank. Router 8's F0/1 is 89.8. And loopback is 8.8.8.8. And F0/0 on router 8 is 58.8. This is 58 here. And 8 here. 58 is in area 20. 8 also, I'm going to put it in, it can be in area 20 or 30. Let me put it in area 30 itself. Let it be there. And we got another network, area 30, 89. Yeah, which is area 30 again. Now let's copy this and put it on router 8. Now one last router I have to configure. Router 5 is already configured, but one side is a new interface. Show IP interface brief. If you see F01 is not configured yet. Interface F0/1, no shared. IP address is 10.58.0.5, 255.255.0.0, IP OSPF 1, area 20. Okay. Now I'll see a neighbor now between 5 and 8. Show IP OSPF interface brief. Between 5 and 8 we have this 5800, 8. Okay, the neighbor has come. Show IP OSPF neighbor. You can see router 5 is neighbor with both router 3 and router 8. And you also saw that router 5 fully belonged to area 20. Whereas router 8 show IP OSPF neighbor. It has got two neighbor. One is router 5, which is 55. The other one is router 9. But they are not in same area. Show IP OSPF interface brief will show you. If you see that F00, which is 10.58, is in area 20. F01, 10.89 is area 30. There are two different areas. Can we call this as ABR? No. Only if you have area 0, it can be called as ABR. ABR should generate type 3 LSA. Type 3 LSA from one area will go to another area. But one of the areas should be area 0. You don't have area 0. So no routes are going to go in between area 30 and area 20. As a result, if you see on router 8, you will see 9999, show IP route, OSPF. You will see 99999. See, it is there, 99999, and it is learned through type 1 LSA. How I know that? Because I don't see IA. There is no enter area. My own area. Router 8 says this is my own area, 99999, area 30. But it won't give it to router 5. Show IP route OSPF. You don't see 99999 anywhere. Okay. Now, the reason is, you can see the reason in router 8. In router 8, if you check the database, show IP OSPF database, you will see in area 20, you don't see 9999. Router LSA, type 1 LSA in area 20, you don't see. In area 30 router LSA only, you see that 9 network. So, it's two different area. You need area 0 in between. So in short, what I want to say is in router 8, if you ping from router 8 6.6.6.6, you will be able to ping. Where is 6.6.6.6? It's here, router 6, the last router. But in router 9, you won't have the reachability. Show IP route, you don't have any route to reach 6.6. You don't have any route to reach even 5.5.5.5. You don't have any route to reach other area. Why? Because only through area 0 it can receive the other area routes. Only through area 0 it can receive the other area routes. That's why. That is why. Fine. So what's the idea? Make R8 to connect to R3, which is also in area 0. R3 is also in area 0. For that, you need to make this path between R3 and R8. What is the path? Between R3 and R8, area 20 is the path. You need to make this path to act as a virtual link for you. You need to make area 20 to encapsulate as area 0. Let's see how to do that. For which you need to know the router ID of router 8 and router 3. Show IP protocol, we'll see in OSPF the router ID is 8.8.8.8. You need to know this. Likewise in R3 you need to know the same, show IP protocol. Here the router ID is 3.3.3.3. Very important, you should know the router IDs. Now if you know the router ID, you can now go to router 3 and say, hey router 3, we are going to have a connection with router 8 virtual. How? Router OSPF 1 virtual link. Area 20 is a virtual link. This is the syntax. You need to say area 20 means the path between R3 and R8 is area 20. This area 20, you cover it as area 0. Encapsulated area 0. That's the meaning of this. Area 20, I want it to form a tunnel. Now, where is the tunnel end? Tunnel beginning is router 3. Where is the tunnel end? Tunnel end is 8888. That's the tunnel end. We are giving the router ID of router 8. Likewise, go to router 8 and say router OSPF 1. Area 20 is a virtual link till where? 3.3.3. As soon as you do this, you will see a link coming up, a virtual connection coming up, and a neighbor established via the virtual link. You see? Router 8 says, I found a neighbor 333 via OSPF virtual link 0, and it is loading to full. Actually, it is like a point to point, so it will load to full. There is no DR-BDR election over the virtual link. Now let us verify. Show IP OSPF neighbor. Look at this. Full relationship, priority 0, virtual link. And what area this belong to? Let's check what area this belongs to. Show IP OSPF interface brief. You will see one interface now called virtual link and area 0. Now router 8 has got a direct membership with area 0. As a result, see point to point. As a result, if you go now to router 9, earlier we were not seeing any routes from other area, but you will see now all of them now. All. And if you wish to ping router 6, you will be able to ping. Likewise, router 6 also will know now the route to reach 9999. Earlier, you were not having any routes to, sorry, this is router 9. Router 6. Router 6. If you check now, you will be able to ping 9999 from here. Virtual link is a tunnel that we create between two routers, that is in an area. In our case, it is area 20. The two routers are router 3 and router 8. Right, so any question on virtual link? No questions on virtual link? Are you comfortable, Rahman?
No, sir.
Rahman, are you comfortable?
Border routers,
Yeah,
right?
between the border
routers.
routers of this path. So the command is, it is area 20 virtual link. Don't put area 30. You are not putting virtual link across area 30. Even though you are putting this virtual link for area 30 to communicate to area 0, don't put area 30 here. You should say the virtual link is across the area 20. So area 20 virtual link, not area 30. Area 30 is what we are trying to combine, no doubt in it. But what is the area in between going to act as a virtual link for you? It is area 20.
Yeah.
I think we have to continue